Mainstream theories of visual working memory construe it as a durable short-term memory store, meaning, unlike iconic memory, it is relatively resistant to masking as well as potential interference from shifts of attention. Results by Makovsky and colleagues appear to challenge this view, however. In several experiments, they found that performance as measured by D' was better in a single probe change detection than the 2FC task. Together, these results were interpreted as indicating that visual working memory was less durable than previously thought. These results are puzzling because they appear to undermine mainstream models of visual working memory. Also, there's an intuition that having more information when you probe for memory as you do in the 2FC task might help with your memory judgments and improve performance. We considered an alternative explanation for these results, which is that performance is not worse in the 2FC task, but people use a decision strategy in some versions of the change detection task, which is not being taken into account. We recognize that it is common for researchers to use lure colors that are a fixed number of degrees away from the target in color space, or that are from a very different color category. What we predicted is that people might use this information about the color of lures in the change detection task to inform their memory judgments. Specifically, people could functionally turn the change detection into a 2FC task by considering what the item may or may not be. So if the probe item is a purple item, they know it might either be a purple or a green item. If they can rule out that it's a green item, they can assume it's a purple item. This type of recall strategy is consistent with a well-known strategy in the long-term memory literature called recall to reject, as well as with evidence that people might employ a memory search strategy in same different perceptual judgments. For the sake of time, I won't talk much about the signal detection theory assumptions that underlie each of the decision rules. I will just note that the standard decision rule in the two tasks, and one assumed by Makovsky and colleagues, predicts the relationship on the left between the two D' primes in the two tasks, whereas if people turn the change detection task into a 2C task, these D' primes should be equal. To test this prediction in our first experiment, we compared performance between variants of the single probe change detection task in which lure colors were predictable and the 2FC task. The types of memory probes in the three tasks are shown here. In the 2FC task, people have to judge if the circle on the left or the right is the target. In the center task, they are shown the probe color in the center, and in the original group, the probe item is shown in the original location. These are the predictions that follow. What's critical to note is that if we assume that the people are treating the change detection task as a 2FC task, D' should be equal across the three groups, and there should be no cost in performance from presenting the probe items in the center versus in their original locations. The results were consistent with our prediction. That is, D' and the two change detection tasks were not statistically different from one another, indicating that there is no cost from shifting attention. Furthermore, D' in the change detection task were equal to those in the 2FC task, consistent with the idea that people are turning the change detection tasks into a 2FC task. A major limitation of this experiment, however, is that the evidence rests on accepting the null. In experiment 2, we wanted to test our predictions in a different way by examining what happens if we break down the predictability of lures and prevent people from turning the change detection task into a 2FC task. To do this, we had two separate groups complete a change detection task. The different lure group could always predict the lure color because it was 180 degrees away from the target in color space. The mixed lure group was presented with lures that were either similar or dissimilar from the target. We fit signal detection models to ROCs constructed from confidence ratings. The first prediction we made is that people in the different lure group, but not the mixed lure group, are treating the change detection task like it's a 2FC task because only people in the different lure group can predict lure colors. This entails that estimates of mu should be larger in the different lure group than in the mixed lure group. We also predicted that effects of item variability should be obfuscated in a different lure group because 2FC tasks obfuscate effects of item variability. Our modeling results were consistent with both predictions. As you can see, mu estimates were larger in the mixed lure group, which suggests that they may have a 2FC task. I will note that all analyses were conditions on trials in which lures were 180 degrees away from the target. Also, the equal variance model performed better in the different lure group, and the unequal variance model performed better in the mixed lure group. Again, this is consistent with the idea that turning the change detection into a 2FC task would hide effects of item variability. And this should only occur in the different lure, but not the mixed lure group. In conclusion, we point out the decision strategies to determine how we can interpret metrics of performance in visual working memory tasks. The experiments I presented to you today suggest that people might not be worse into vFC than a change detection task. Instead, people may employ different strategies in change detection tasks, which can inflate estimates of visual working memory sensitivity if these strategies are not taken into account.